Welcome to True Projects. In this video, we are going to explain about the project, which is cross-platform reputation generation system based on aspect-based sentiment analysis. Existing reputation generation system lack the ability to effectively process reviews from various platforms, filter out spam, provide nuanced assessments, and offer advanced visualization tools. This creates a significant gap in providing consumers with reliable information for decision making. This project is necessary to address these limitations and provide consumers with more reliable and comprehensive reputation information when making decisions about products and services. It aims to improve consumer trust in online reviews. This project collects and processes the data from multiple platforms, uses spam filtering and aspect-based sentiment analysis to analyze reviews, and considers factors like review popularity and time to calculate reputation values. By incorporating these elements, the project seeks to provide a holistic and data-driven reputation assessment. The primary objective is to create a robust reputation assessment system for online products and services, ultimately improving consumer confidence in online purchasing decisions. The project aims to utilize machine learning and deep learning algorithms, including natural language processing, and the algorithms are Naive Bayes, BERT, Robota, GRU, LSTM, CNN, Ensemble model to effectively process and understand the content of consumer reviews on various online platforms. These algorithms extract meaningful insights from reviews, filter out irrelevant content, and apply mathematical models to calculate reputation scores. This ensures accurate and reliable reputation assessments, empowering consumers to make informed decisions, thereby increasing their satisfaction with online shopping experiences. For implementing the project, we need hardware and software requirements. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8GB and above, and hard disk of 25GB and above. Coming to software requirements, we need Anaconda 3 and Visual Studio Community version. In the flow of work, we have designed few modules to implement the project. The first one is importing the packages. This module involves importing the necessary libraries and packages which are required for project execution. NumPy is imported for numerical operations, Pandas for data manipulation, TensorFlow for deep learning, Matplotlib and Seaborn for visualization, Scikit-learn for machine learning, and transformers used for natural language processing. Exploring the dataset. This step involves examining the dataset to understand its structure, contents, and characteristics, particularly for the aspect-based sentiment analysis. Data processing. In this phase, data is prepared and pre-processed to ensure that it is in suitable format for analysis and reputation generation. Visualization using Seaborn and Matplotlib. This module involves creating visualizations of the data using Seaborn and Matplotlib. It gains insights and understands patterns. Data cleaning. This step involves identifying and handling missing data, outliers, or any inconsistencies in the dataset to improve its data quality. Tokenization and aspect-based sentiment analysis. This module focuses on tokenization and aspect-based sentiment analysis techniques, which are crucial for extracting sentiments related to specific aspects or products or services. Splitting the data into train and test. In this step, the dataset is divided into two subsets, which are training set and a testing set, which are essential for evaluating reputation generation models. Building the model. In this, we build various models of deep learning, which are Naive Bayes. It is a probabilistic classification algorithm used in this project for its simplicity and efficiency in classifying text data based on sentiment, making it suitable for sentiment analysis and tasks. BERT, which is a bidirectional encoder representations from transformers. It is a pre-trained transformer-based model used for tokenization and transformer learning, enhancing the accuracy of sentiment analysis by capturing contextual information from the text. Robota. It is a robustly optimized BERT pre-training model. It is an optimized version of BERT. It is employed to further improve tokenization and transfer learning in sentiment analysis, enhancing model performance. GRU, which is Gated Recurrent Unit. GRU is a type of recurrent neural network used in this project for its ability to capture sequential dependencies and analyze textual data effectively. LSTM, which is long short-term memory. It is another type of RNN used in this project for its capability to capture long-range dependencies in the text data, contributing to improved sentiment analysis accuracy. CNN. It is convolutional neural networks. It is used for their effectiveness and capturing local features and patterns in the textual data, enhancing sentiment analysis results. Ensemble model. It combines the predictions of multiple models to improve overall accuracy, providing a more robust and reliable reputation assessment system. Coming to training the model, this step involves feeding the training data into the models to train them and optimize their parameters for generating reputation scores. Flask framework with SQLite for sign up and sign in. This module involves setting a web application using Flask and using SQLite as the database for user sign up and sign in functionality. User gives input. User provide input which is processed and translated as needed for reputation generation. The trained LSTM model is utilized for prediction. The given input is translated and pre-processed for prediction. Trained model is used for prediction, which is LSTM model. Final outcome is displayed through frontend. The results of reputation assessments are displayed to the user through the project's frontend, providing them with the valuable insights into products or services, reputation across different online platforms. For execution of the project, we need to open the code folder. This is the code folder which contains the source codes. This is the static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages that are used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model file which contains the algorithm information, and this will be loaded into the project code during runtime. And these two are the IPYNB files. This is the Jupyter Notebook files, which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells. This is the sign-up file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So now we will copy this and open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. This is used to change the current directory to the code folder's path. So the current directory is changed to the code folder's path. Here we need to type python space app.py. This will compile the app.py file. This command is used to execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we need to click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is localhost and the port number, unless it is configured differently. So, this is the localhost and this is the port number. Now we need to copy this local link provided by the framework and paste it in any web browser. Now we will copy this and paste it in the Chrome. Here I'll paste the link and then click on enter. This is the homepage of the project, which is displayed in the web browser. This frontend is built by using the Flask framework. Now we need to click on sign up. Here we need to enter all the registration details if we are registering newly. I have already registered, so I'll directly click on sign in. Here we'll give the username and the password and click on sign in. So this has redirected to the home page where we need to enter the input message in the input box. Here we will enter the message. I gave the message in the input box. Now we will click on predict. So for this particular tweet, it is predicted that the sentiment of the tweet is neutral. Now we will give another tweet. So here we will give the another tweet. I entered the message here. Now we will click on predict. So it is predicted that the sentiment of the tweet is positive. Now we will give another sentiment. Here we will give the tweet. I entered the message here. Now we will click on predict and see what will be predicted. It is predicted that the sentiment of the tweet is negative. Now we will give another tweet. I entered the message here. So for this message, it is predicted that the sentiment of the tweet is extremely positive. Now we will give the another tweet. I entered the message here. And for this message, it is predicted that the sentiment of the tweet is extremely positive. In this way, we can enter any message. For that message, we will get the predictions which are extremely positive, extremely negative, positive, neutral or negative. Now we will sign out. We have successfully developed a robust cross-platform reputation generation system based on aspect-based sentiment analysis and advanced algorithms. This system enhances the accuracy of reputation assessments for a wide range of online products and services. Primary focus has been on empowering consumers with reliable and comprehensive reputation information by considering aspects like review authenticity, specific sentiments, and review dynamics. We provided consumers with a valuable tool for making well-informed decisions in the online marketplace. As online commerce continues to grow, the importance for trustworthy reputation assessments system becomes increasingly critical. The success of our project opens doors for further research and enhancements in the field of reputation generation with the ultimate goal of improving consumer satisfaction and trust in online transactions.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.